Previously, we've been working on graphing polynomials and getting used to like what to look for. We're looking at the leading term, at the leading coefficient to see how it opens, and we're looking at the degree and we're finding zeros. Now, previously we would do problems like this where it's already factored. So now we have to deal with the case, what if it's not broken apart like that? How are we supposed to find the zeros? Well, let's start with the easier ones. Now, easy is a relative term. It depends on your comfort with factoring. So let's start with something fairly straightforward. Now that is a polynomial. It is a quartic one, which means, well, first of all, it has a leading coefficient that's positive, positive 1. And, excuse me, it has a degree of 4, which is even. And now we need the zeros, and I can't tell what they are in the format it's in. So what I have to do is I have to take this, let me rewrite it over here, and I have to factor it. So the first layer of factoring is, I call it undistributing. See how an x squared goes into both of these terms? So if I pull that out, what I'm doing is dividing it out. I'd have an x squared left here and just the minus 9 left there. Now that's partially factored. We gotta go a little bit more. So here's this x squared, and this factors, this is a difference of perfect squares. So this is going to be x minus 3 and x plus 3. So I've taken the given equation and I've factored it so it matches what we did last time. And now my zeros would be x equals 0, x equals 3, and x equals minus 3. These have a multiplicity of 1. And this one, the 0, has a multiplicity of 2. So factoring, it's the same stuff, but I have to factor now. So let's look at what the graph looks like. Have to get out to 3 and negative 3. And I have zeros at 0, minus 3, and plus 3. If I have a positive leading coefficient and it's even, that is going to be a parabola or a W shape. So let's see, I know I have to go high on the left and high on the right. So this is going to, for the minus 3, it's going to go through because it's got an odd multiplicity. And I have to go through and loop back up to hit this 0. And that one's going to bounce because it's got an even multiplicity. And then I go through because that's got an odd. So I get that W shape. All right, let's go for example number 2. Y equals x5 minus 5x to the 3 plus 4x. Now in this problem, I see I get an x in all terms, so I can undistribute or factor out that x. And that's kind of like a quadratic. So this is, that looks very similar to this. This is factorable. And that's just kind of cranked up a little bit in the exponent. So this is going to pull down. And this is going to factor very similarly to this one. Now the thing is though, because this is the factorization, those are both difference of perfect squares. So this breaks into x plus 2, x minus 2. And this breaks into x plus 1, x minus 1. So that's got 5 zeros. So let's see what we have here. We'll do a quick sketch. We have a leading coefficient that's positive. We have a degree that is odd. We have zeros, all with a multiplicity of 1, so it's going to go through all of those. X equals 0, minus 2, plus 2, minus 1, and plus 1. So that's all my information there. Now to put it on the graph, let's see, we don't have to go very far. We have 0, the 1s, and the 2s. All right, positive leading coefficient with an odd degree, that is cubic look, or cubic with a squiggle there. So it's low, goes low on the left, and high on the right. And these all were a multiplicity 1, so we're going to go through each time. And we get a lot of moving in and out, but it ends where it's supposed to end. So, like I said, those aren't too bad because you can factor them. Now, if you have trouble factoring, that's going to be difficult, but you're going to like that better than what's coming next. So, the next ones are not factorable, at least not easily factorable. So let's start with this one. Now this one you could actually factor with a method called grouping, but let's assume you do not know how to do that. So the way you have to, it's kind of a educated guess and check. So we're going to try certain x values, and we hope to get 0 when we plug the x value we're trying in. So this is kind of like annoying because you just got to kind of guess things. Only try numbers that go into the constant term. That would be the just number term. So for this problem, I could try to plug in 1 for all the x's to see if it equals 0. I could try minus 1, I could try plus 3, or I could try minus 3. I would not want to try 2 because 2 doesn't go into that number. So normally you start with the easiest ones. Let's try, I'm going to just put here x equals 1. So I'm plugging 1 in. Let's see what we get. 1 minus 3 plus 3. And if you add that all up, that equals 0. So right out of the gate, I got a correct answer, meaning it equaled 0. So what do we do with that? Here is the logic. Since x equal 1 gave me 0, x equals minus 1 is a 0. X equals 1 is a 0, and x minus 1 is a factor. Now that throws people, right? X equals 1 worked, so x minus 1 is a factor. Well, let me just finish out the problem and see if this makes any sense at all. And I'll try to link these two together. So what we're saying is since 1 worked, then that is a factor. And when you say it's a factor, it means you could factor that. This times something will equal that. Just like for 12, we say 3 is a factor because 3 goes into 12. But to factor 12, I would go 3, right? You would hook it with its pair. 3 times what equals that 12? That's factoring. So I know this goes in evenly, like 3 goes in evenly. How do I know? Because when I plugged in 1, it equaled 0. I did have to switch the sign. How do I get that other term? Here's where our unit on division comes in. See, if I wanted to know what is that number if I'm factoring, how would you find it if you didn't just know it in your head? Wouldn't you go 12 divided by 3 to get that? What if I crank this up a little bit? What number would go here? Wouldn't you get out your calculator and press 1200 divided by 3? So we want to divide that number by that number to get the other factor. We want to divide this polynomial by that to get the other factor. So now we're going back to the division. Now personally, I would like to use synthetic here. So let's see if we can remember how to do that. 1x cubed minus 1x squared minus 3x plus 3. And here I'm going to switch the sign. Notice I'm back to what I originally plugged in. I know that gives people a headache. And now the process is to pull this one up, multiply and add, pull that up, multiply and add, pull that up, multiply and add, and there's no remainder, and it's important that there's no remainder. So this is what goes up here. This is the number, this is the x, and this is the x squared. So x squared minus 3 is my other factor. Well, I still have to get the zeros. This is part of a larger problem. So what I'm going to do is I'm going to set this equal to 0, and I'm going to set this equal to 0. And see, that's why I had to switch that sign, because we need to get this back as a 0. And this one, I think it's easiest if we move the 3 over, and we get plus or minus the square root of 3. So if I do a quick sketch, I would have minus the square root of 3, plus the square root of 3, and 1. And this is positive and odd, so this is going to start low and end high. So this would be positive root 3, negative root 3, and positive 1 right there. So that's just a real quick sketch to tie it in with what we've been doing. As you can see, though, the part you've got to focus on, the part that's going to be challenged, is what just happened here. What did I do with that 1? I plugged it in to get 0. And then you got to switch the sign. That's something you got to remember. How did I get that? I divided this by this to get that. And then you see the rest before you. We definitely need to do that again. We're going to do 2 more examples before I think you might be able to try some. Get a little more space here. Alright, so we have y equals so let's see, what's the process now? You might want to actually write this down like process. I don't have a lot of room here, but as I say them, you can kind of keep them off on the side in a list. So the first thing I do is, well, thinking-wise, I think, what numbers can I try to plug in? See, I'm going to try to plug numbers in for x and hope I get 0. So in my head, I'm thinking 1, 2, 4, or 8, stuff that goes into that constant number. Or they could be negative. But I wouldn't try 3, wouldn't try 5. Now, if I do my procedure, first thing, plug in numbers. Not just any old numbers, those numbers. This is like very short, like overview. So normally you try the easy ones. Let's try x equals 1. And 1s are easy to plug in. 2 plus 7. Let's see, that is not 0. Nope. How about minus 1? This would be minus 2. This would still be plus 7. Minus 2 minus 8. Nope, that doesn't work. You can add them up and check for yourself. Those do not equal 0. Let's try 2. Notice I tried the easiest ones. 2 times 8 is 16, plus 7 times 4 is 28, plus 4. No, that's too big. Let's try minus 2. 2 times negative 8 is minus 16. That would still be positive because you're squaring it. This is minus 4. This one might work. Let's see. That's minus 20, minus 28. Yes, that works. So finally, had to go through a few, but I found it. That works. Plug a number in, try to get 0. Then what? What's our second step? Well, so x equaled minus 2 worked. So what I'm going to do is I'm going to write x plus 2. See, that's a factor. And now I need to find the other factor. That is my next thing to do. Find other factor with division. Right? I know that's hard to read, and I'm writing real small, but you can like do the closed captions. You can like write this down and pause it while I'm going. The second thing I do after I first thing, plug a number in, try to get 0. That's what worked. Then I need to write it like this, and I'm going to try to find the other factor using division. Find the other factor with division. So I'm dividing this by this. And I'm going to do this synthetically. Pull this up, multiply. Pull this up, multiply. Pull this up. Oh, something's off here. Give me a second, I gotta track this down. Oop. Pull this up, multiply, and 0 remainder. So I saw that that wasn't going to be a 0 remainder, and that's what was kind of freaking me out there. So sorry about just sitting there watching me think, but that was the problem. I did my division incorrectly. So that worked out well. This is what goes there after I put my x's back in. So this is my number, my x, and my x squared. So I'll write 2x squared plus 3x minus 4. Okay. Now that's a quadratic. So you got two choices. You can factor it, or if you can't factor it, you got to use the quadratic formula. So I'm going to put 3, finish factoring, slash solve, or let's put get the zeros. So it's kind of like one way or another. Step 3, you're either going to finish factoring. Here's this one. So let's see, 2x times x. I think we're going to go 2 and 2. Let's see, would that be right? 4 and 2, that won't work. This looks not factorable. So I can't finish factoring. So I got to find the zeros. So since I can't factor it, I got to set it equal to 0 and solve, which means quadratic formula there. So this one's easy, but this is going to be negative b squared minus 4ac all over 2a. Let me get my calculator. So this is 9 plus 32 plus or minus root 41 over 4. This is 6.4. So I'm going to get x equals minus 3 plus 6.4 divided by 4. Minus 3 minus 6.4 divided by 4. So there are my zeros. Okay. So let's play through that again. What did I do? I tried numbers, I plugged numbers in that went into this 8 until I got 0. That worked. That made this as my factor. Step 2, divide this by that, and this answer here is your second factor. Step 3, if you can factor that more, do it. If you can't, you got to solve it with the quadratic formula there. And this spits out my other two answers. So this is my first 0, and this is how I get my second 2 zeros. Now what do I have to do? Well, now I'm going to graph this thing. So I know that the leading coefficient is positive. I don't think we've done one that was negative yet. We see that the degree is odd, which means it's this shape or this shape, which means it starts low, ends high. 1, 2, 3, 1, 2, 3. So I have one at -2, -2 1/3 about, and 0.85. It's low and high. And these would all be multiplicities of 1 because there's no quantity squared here. So I'm going to go through, and that would be a picture of my graph. All right, I know those are tough. We're going to do one more example. We'll run through one more, but it's important that you try these. You know, rewatch the video if necessary, or Google, try to find other ones where you, like I would type in the search bar, finding zeros of polynomials, and see what you can find if this isn't clearing it up. Let's try one more though and see how it goes. Okay, so let's say we have y equals x cubed plus 8. Well, that's weird because it's so short, right? So look, it's 8 again. The numbers to try would be 1, 2, 4, and 8. So let's just try plugging in x equals 1. 1 plus 8, no. X equals -1. -1 plus 8, no. And hopefully, you know, if you're thinking about it, -2 kind of pops out at you, because that would be -8 plus 8. That's 0, and that's good. So that works. X equals 2 -2 works. So that was step 1. Plug stuff in and try to get 0. Then what? Oops. So now I'm factoring this. And this, if I switch the sign, is my first factor. And I'm trying to get this other factor. And to do that, I have to divide. So I'm going to use synthetic. And now you got to be careful here. See, you're missing the squared in the x term. So I have 1x cubed, no x squareds, no x's, and 8. And I got to switch that sign. So there's your setup. Pull this up. Multiply. One more time. Got to get 0 as a remainder or else there's an error like I just made. This is your second factor, number x squared. So this is x squared minus 2x plus 4. Okay, good so far. Now we got to find the zeros. I think about it, can't factor that. So I'm going to set these equal to 0. Step 3, find the zeros. This one's easy. This is the one I knew from the beginning. This one I got to use the quadratic formula again. Negative b plus or minus the square root b squared minus 4ac all divided by 2a. X equals 2 plus or minus the square root of 4 minus, that's negative. This is the square root of a negative, so I'm not going to get any zeros. I did all that work and it doesn't contribute any zeros. But the good news is I can shut that down. I don't got to worry about it. There's only one 0. So let's try to graph this. Leading coefficient, positive, again. Degree, odd. So it's going to be this shape or this shape. And there's only one 0. 1, 2, 1, 2, 3. So here's my 0. It's got to start low and go high, and that's the only, so it's just that shape, right? We haven't done one yet where we just got that, but there it is. Give them a try. Email me if you have questions, and next thing will be the test. So be sure you're doing the practice. Take care.